Let's have a look at the index of hydrogen deficiency. That sounds like an arcane subject, but it's actually very useful. This is Dr. B, and you can perhaps say it a little cleaner. Hydrogen index of hydrogen deficiency is what they call double bonds equivalent, double bond equivalence. And what's that? That's the sum of double bonds and or rings in a substance. Why is it handy? Well, if you got a molecular formula, you're going to start drawing substances, and you're going to be drawing too many. This will limit it. If you know that the substance has two double bond equivalents, meaning say one double bond in a ring, or two double bonds or one triple bond, you're greatly limiting the number of possible choices. So it's a nice quick way to evaluate a molecular formula. Let's do this by example. We're going to be doing this in a relatively long way, but I think it's worth it because it's going to show you where the ultimate formula that you're going to see down here is derived from. And it also shows you some shortcuts where you don't have to use that formula at all. Be aware that if this does seem tedious to you, you can just grab the formula at the end, use it, and it will be applicable. But let's go through the process. Say we've got some hexane. Here's its skeletal formula. You should recognize that as CH3, CH2, 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 CH3. That is C6H14. How many rings does it have? I don't see any. How many double bonds? I don't see any. How many triple bonds? I don't see any. What is its index of hydrogen deficiency? It's 0. Notice that it's CnH2n plus 2. For hydrocarbons, that's a quick shortcut. If you see twice as many hydrogens plus 1, then IHD is 0, end of story. Hexene has a double bond in it. I expect this to have an index of hydrogen deficiency of 1. One double bond and or ring, and this one happens to be a double bond. C6H12 makes sense, right? CH3, CH2, 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 CH, CH2. No rings, one double bond, no triple bonds, 1. Cyclohexane has a ring. And I hope that you see when you evaluate this, and this is the chair conformation. You could easily just draw a hexagon, which is a little cleaner to use, but hey, CH2, 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 C6H12. I guess when you form a ring, you lose those two tip hydrogens, right? When this thing comes around, it gets two hydrogens smaller. That's why we have to say double bond equivalence. You lose two hydrogens when you turn a single bond into a double bond, right? Instead of being CH2, that's CH. Instead of being CH3, that's CH2. And so it's the same kind of thing. That's why we have to use these weird words. So C6H12 has one ring, no double bonds, no triple bonds. And there it is, index of hydrogen deficiency of 1. Cyclopentadiene, sparing you the trouble of going through the details now. C5H6, that's CnH2n minus, what is it, 4 or so? And that is a ring and two double bonds, IHD equals 3. Aspirin, we should be able to do this. Let's go right to the answer. I see 3, 4, 5 double bonds and a ring. I think that's an IHD of 6. Bammo. Ethyne has a triple bond, which is the same as two double bonds in terms of addition, so the IHD there is 2. Fine. What are we finding? You should be seeing that carbon tends to form 4 bonds, etc. Let's do it in order. Hydrogen tends to form 1 bond, oxygen 2, nitrogen 3, carbon 4, honk if you love chemistry, and halogens, just 1. What's the relevance? Well, if you have a formula of CnH2n plus 2 like this, your IHD is 0. If you have CnH2n like this, your IHD is 1. That's just a faster way to do it. If you're losing 2 from it, like C5H8, you would have IHD of 2. What happens when you add oxygen? Well, if you draw it out, if you draw methane and then draw also methanol, you'll see you don't have any double bonds rings. It's a spacer, right? It's a spacer. It does not affect anything. So oxygen doesn't mess it up. So if you see C2H6O, don't worry about the O. That's 2n plus 2. It's still got an IHD of 2. Similarly, if you look at amines, adding nitrogen adds 1 hydrogen, so it's going to change it a little bit. If you have a halogen, adding halogen loses 1 hydrogen, right? CH4 versus CH3, we added 1. CH4 versus CH3 here, we lost 1. So I should say this is 4 versus 5. You see those two hydrogens there? There you go. Fine. So toss that all into your brain and come up with a formula. And don't, because I'm just going to give it to you. The index of hydrogen deficiency is equal to half the sum times the sum of twice the carbons and 2 minus the hydrogens minus the halogens plus the nitrogens, right? It's good just to know this formula and plug it in. And yes, this entire experiment here is unnecessary. You can just take this formula and solve it for anything. But I hope this helps you see where it all comes from. Let's apply it. Give me the IHD of all these substances. Now, honestly, there's no reason even to write the molecular formula for these. You just add them up. Benzene, 3 double bonds in a ring is 4. Cyclobutane, 1 ring is 2. 1 ring is 2. 2 double bonds in a ring is 3. Aspirin we did before, it's 6. Acetylene we did before, it's 2. And these, I'm going to leave these as an exercise for you, but just plug directly into this formula and you should get the index of hydrogen deficiency of these substances. This is a introduction to index of hydrogen deficiency.